This time we shall be taking our new topic, magnetic effects of electric current. In magnetic effects of electric current, we shall be seeing how the magnetic effects are being produced by a current carrying conductor or any coil through which charges are being flown. Then we shall be discussing the topic about magnetic field lines, their properties, how they are being set up by any source. Then we shall be taking our Oersted experiments, and along with that we shall be switching on to magnetic force and the principle of electromagnetic induction and two major practical applications, that is our DC motor and AC generator. Let's start today with these three topics. First, introduction. Number second, magnetic field. Number third, activities related to magnetic field lines that are very important for our board's examination. Number fourth, properties of these field lines. Alright, let's start with the first one, that is our basic introduction. In earlier classes, we have already discussed two major effects of current. Those were chemical effects of electric current, which we have already read in our 8th standard. Next one was our heating effect of electric current that we took in our electricity chapter. In this chapter, we shall be solely discussing about magnetic effects of current. Current, as we all know, that current is only due to the charges when their state is of motion. So charges in motion comprise our current, and since when we are saying that current is showing our magnetic effect, that means any charge which is moving will definitely show the magnetic effect. What happened earlier, if we just speak of the term magnetic effect, earlier before 1800s, electricity and magnetism were taken as solely independent phenomena. But what happened in 1800 that we need to discuss about magnetic effects of current? In 1820, there was a scientist named Oersted. He was doing an experiment using a current carrying conductor, and there was a magnetic needle kept beside it. In his experiment, there was a conductor in which current was flowing, and there was a magnetic needle kept over here. Let's suppose this is our magnetic needle. He noticed that whenever current was flowing through this conductor, this magnetic needle was showing some deflection. That was a major revolution in the science field. After that, he concluded that moving charges create magnetic field around them. And when we speak of moving charges, that means we are saying that any current carrying conductor is showing magnetic effect or producing magnetic field around it. By this statement, by this conclusion, we now study the magnetic effects of current. After this conclusion, electricity and magnetism were then studied as an interdependent phenomena. Alright, let's start with our chapter magnetic field. Since these moving charges are creating magnetic field, so let us first start what a magnetic field is. Coming on to our next topic. Just as we have discussed in electricity the concept of electric field, similar to that concept we have got our magnetic field. So magnetic field would be any region or space around any magnetic source in which if any magnetic material, let's say for example iron nails or some cobalt pins, any magnetic material is when kept inside that field, that material would experience a magnetic force. That region or space is known as magnetic field. So definition would go like, the region or space around any source, this source would be the one producing magnetic field, in which the force that is produced due to this source would be the magnetic force. Its nature would be magnetic. Is experienced by a magnetic material or substance. For example, iron, nickel, cobalt, etc. Alright. This be our magnetic field. Here we have taken the term source. So what are those kind of sources which produce a magnetic field around them? These sources are categorized as two. First one that we are already aware of, that before the interdependence of electricity and magnetism, these sources were known to people. The earliest sources of magnetic fields were the permanent magnets. Okay, but what about the latest sources? After 1820, the next source that we came to know for the production of our magnetic field was our current carrying conductors. Let us discuss about these two sources. What are their nature? What are their characteristics? Okay. Sources of magnetic field. We shall be discussing two kinds of sources. First one, permanent magnets. Second one, our current carrying conductors. Okay. Permanent magnets. These sources were known to us since ages. The first introduction of the permanent magnets was given to the world when in Greece a shepherd, he got his iron feet and iron shoes stuck on a naturally occurring rock. That rock was lodestone, an ore of iron, that is magnetite. After that, Chinese took these permanent magnets, or Chinese used these permanent magnets for the explorations. How so? They checked that these magnets, when hanged freely, they always oriented towards north-south direction. Chinese sailors used that property of permanent magnets for the exploration on the seas and lands. Then afterward, there were many other applications of our permanent magnets that we see nowadays, such as our refrigerator magnets or the magnets used in our DC motors. Those are also applications of permanent magnets. Permanent magnets. These are our earliest sources. The most common form that we use is our bar magnet. The properties are, first one, if brought near to the iron nails, they attract them. That means they have got attractive property. Next property, if held freely, they always orient themselves in north-south pole, north-south direction. That is known as our directive property. They always align themselves in north-south direction. Next property, these magnets, let's suppose I am taking simply a bar magnet. The two ends of a bar magnet on which maximum amount of attraction for the iron nails is shown, that point are called poles. And for any magnet we always get pair of poles, that is monopoles never exist. One pole is known as north pole, which align itself in the north direction. Another pole is known as south pole, which aligns itself in the geographical south direction. Alright, next one. For any permanent magnet, what we say the surest test of magnetism is when we bring two permanent magnets together and their like poles are towards each other, they always tend to repel each other. That test is called repulsion test, and repulsion is known to be the surest test for magnetism. Alright, now coming to our current carrying conductors. These are our latest sources. In 1820, Oersted brought this knowledge to the world that any current carrying conductor produces or deflects any small magnet kept near it. That means any current carrying conductor or moving charges per se produce magnetic field around it. Its most common applications that we find today is in cranes, in iron scrap industries.